Right, so we are starting a new chapter today. This is chapter 7. It's all about geometry, and you know we always start off a new lesson or a new chapter with lesson 0, which is all about prerequisite skills to help us with the rest of the chapter. So let's get started. First, we're going to talk about angle classifications. And classifications are ways to group angles with other angles that have similar qualities. So our 4 classifications are acute, right, obtuse, and straight. And you're probably very familiar with all 4. Acute angles are greater than 0 degrees and less than 90 degrees. If we want to draw an example, we would draw an angle that is less than 90. Don't forget to put the arrows at the ends of your angles to show that those rays go on forever. A right angle measures exactly 90 degrees. So right angle looks like a sharp corner, like the corner of a room, and usually they'll draw the box in the corner, in the angle to prove that it's 90 degrees. An obtuse angle is a larger angle. They're greater than 90 degrees and less than 180 degrees. So we'll draw an example of an obtuse angle. Okay, so this is larger, open more than a 90-degree angle. And finally, a straight angle measures exactly 180 degrees. And a straight angle looks just like a straight line, and let me tell you this, there is no difference. Straight angles and straight lines are the same thing. We just name them a little differently sometimes, but please know they're the same. Okay, let's talk about naming angles. Naming angles is different. So classifying was putting them into groups based on their qualities. Naming angles is when you're talking about a very, very specific angle. So if I say the name of the angle, you know exactly where to look. So here's our example angle. We're going to name it in 4 ways. This Q is very important. The Q is called the vertex point. It's where the 2 rays intersect. So that Q you're going to see is it's used very intentionally when we name our angles. So we're going to start off with the 3-letter name. We can call this angle PQR. Angle sign PQR. Notice the Q is in the center when I put my 3 letters. That's really important. Q is the vertex, R is on the other ray, and so that order is really important. We could name this in reverse as well. Angle RQP is another name for this same angle. You cannot put the R in the middle or the P in the middle because they're not the vertex. So that Q is very important. It is the vertex point. We could also name that angle just by its vertex. The only reason this works is because this angle is not attached to any other angles. Okay, if this were attached to 2 or 3 more angles, we couldn't just call it angle Q because there would be too many angle Qs. Last but not least, we can use this number sitting inside the angle. That number 4 is not the angle measurement. It's not the number of degrees. It wouldn't even make sense because 4 degrees would be an acute angle, and this is clearly an obtuse angle. So that 4 is just another way for us to name the angle. And you'll see all 4 of these methods utilized throughout the rest of the chapter. All right. Next, let's talk about some basics of geometry. Let's talk about points, line segments, rays, and lines. When you're taking these notes, I want you to be very, very, very accurate in how you write each answer. We need to use the correct symbolism, and that's going to be a big part of this piece of the next quiz. So points, we have a lot of points here on this diagram. We've got point A, point B, point C, point D, point E. So we can name any of those points. We'll just do 3 of them. Point A, point B, and point C. I'm just going to use a little point here to kind of be our symbol for points. Now, a line segment. Line segment, remember, that is a piece of a line. It has a starting point and an ending point. So the first line segment that jumps out to me is this guy right here, line segment CE. Doesn't have any arrow going off beyond here. Doesn't have an arrow here. Okay, we're just talking about the segment itself. Pardon me. Let's fix that up. There we go. So we're just talking about this starting and stopping point and everything in between. Okay, so we're going to call that line segment CE, and to write a line segment, we put its end points down first, so end point C, end point E, and then we put a little mini line segment on top of it. And you can add the end points here, or you can just draw it without any arrows. So I'll show you both ways in a second. So that's a line segment, but guys, I'm going to tell you something. There's a lot of other line segments here. We just have to be choosy in how we talk about them. So if I choose endpoint B and endpoint C, and I talk about this piece that connects them, that is a line segment too. Even though there's arrows over here and over here, the line segment is just part of that line. So a line segment I can talk about here is line segment BC. Put a mini line segment on top. This time I'm not going to put the dots, just going to put a little line segment. And if I write it like that, because I'm using line segment notation, we all know to start here and end here and don't go any further. Okay, one more line segment. We can grab a whole bunch, by the way. There's lots more on here, but let's talk about line segment BA. Line segment BA starts at B, ends at A. Don't worry about the arrow here. It's not part of the segment. The segment is just this section right here, and we are going to name it correctly, line segment BA, with a little line segment on top. Now we're going to talk about rays. A ray is an arrow. When I think of a ray, I think of an arrow. A ray has a starting point, but it goes in one direction forever and ever and ever. Okay, so when I think of rays, I think of this guy right here. I've got a starting point, and then I've got this arrow that goes on forever and ever and ever. That is a ray. So how do we name a ray? We have to name a ray starting at its starting point and traveling toward the arrow. So we're going to name this ray BA. Okay, start at the starting point, go through the point, and continue up that arrow. Now we need a symbol on top. You draw a little mini ray. The little mini ray symbol always points to the right, and the letters always start with the starting point and go toward the arrow. So see here we have ray BA, we have line segment BA, but they were two different things that we talked about. Ray BA goes on forever, line segment BA ended here at point A. So they are different things based on the symbolism that we use. A couple more rays really quickly. I can talk about ray BD. Ray BD. So that would be the ray starting at point B, traveling to point D and beyond. So ray BD. Don't forget the ray on top. And let's do one more. How about a different direction? Let's do ray CB. Ray CB starts at C, travels through B, and continues forever in that direction. So starting point is C, goes through point B, and it continues forever. That's a ray. Last but not least, it asks us to name the line in 3 different ways. So there's only one line in this whole diagram. The line itself is this guy right here. And the only reason that that's the only line is because it's the only part of our diagram that has an endpoint, an arrow and an arrow at both ends. Okay, so that is our line. We can name that line in 3 different ways, and what I mean by that is all 3 of these names mean the exact same line. So we can choose any 2 points from the line to name it. It's always 2 points. So we can name it line BC, and we'll put a mini line at the top, arrows on both ends. We could name it line CD, arrows on both ends. Or we could name it line DB. Any 2 line segments, or any 2 points on the line can be used to name that line. Okay, and a line travels in both directions forever. Okay, a couple more things here, a couple notes. If I go a little quick, you can pause and get caught up with your notes, your fill in the blanks here. We got parallel lines, are lines traveling in the same direction that will never intersect. Parallel lines would be something like this line and this line on my diagram here. Same direction, they will never intersect. Okay, perpendicular lines. Perpendicular lines are lines that intersect at a right angle. So it's a little bit hard to understand perpendicular from this particular diagram, but I'm going to do my best to explain it to you. Perpendicular, so if I talked about this line segment here and this line segment here, even though they don't look perpendicular because it's a perspective 3D drawing, they are perpendicular because this would be a box. And this would be the front edge and that piece that's traveling back to connect the other base, and they would meet at a right angle. Okay, so you would see them meet like this. That's perpendicular. Last but not least, we're going to talk about skew lines. Skew lines are lines that lie in different planes, are not parallel, and will never intersect. So I chose this diagram very purposefully so we could talk about skew lines. So this idea of different planes, each one of these faces could be considered a different plane. Okay, so skew lines has to happen in 3 dimensions. They are lines that are not parallel, but they're also never going to intersect. So you need a line on one face and a line on a totally different face of a 3-dimensional object like this. And those 2 lines cannot be going in the same direction, but they're never going to intersect. So let's talk about this line right here. This line or line segment right here. And then we'll talk about this line segment right here. So, see how they're not traveling in the same direction. They're definitely not parallel, but they're also never going to intersect because this line segment here, if we continued it forever and ever and ever, it would keep going in both directions in the back of that prism. And this line segment here is kind of above it, and it would continue, but they would never intersect because this is raised above that line segment right there. Okay, so skew is an idea that happens in 3 dimensions, not parallel, but will never intersect. Play around with this diagram and see if you can find some more skew lines and line segments. Okay, same idea here in this problem. Name all line segments that are parallel to line segment AB. So here's line segment AB. The line segments parallel to it are line segments CD, line segment EF, and line segment GH. So we've got line segment CD, EF, and GH. Okay. Next, we're going to talk about perpendicular. Perpendicular, I'll draw them in red. Perpendicular to line segment AB. Well, this line segment is perpendicular, line segment AE, and this one is perpendicular, line segment FB. Maybe we can clean this up a little bit, get rid of some of these blue lines. So they're pretty clearly perpendicular, but we also have these two, line segment AC and line segment BD. And that's because, picture a tissue box or a shoe box, you have all those right angles going on. So we have line segment EA, line segment AC, line segment FB, and line segment BD. And they're all perpendicular to line segment AB. Okay, last but not least, we're going to talk about skew. So skew, we can't have them parallel, we can't have them perpendicular. They have to be traveling in different directions, but will in this 3rd dimension. They're never going to intersect, they're not parallel. So we'll do these in green. So we're talking about line segments like EG and HF. So they're never going to intersect, but they're also not parallel. And we could also include line segments GC and line segment HD. Okay, they're not parallel to AB, they're not intersecting AB, so they are skew. So these 4 segments are line segment EG, line segment CG, line segment FH, and line segment HD. All right, so definitely review some of these notes. I know that parallel and perpendicular are probably reviewed, but skew is new. So play around with skew, make sure you understand it, and ask any questions in class.